Alright guys, welcome back to my channel. We got another Super Samurai build series. The next thing that we're going to do on this episode is build the front forelinks. So I got this axle set up here. I'm using some plumb bobs, some levels. I got these leveling jacks to get everything nice and plumb with my truss and my pinion angle, which is about 7.5 degrees. I'm using this level here to make sure everything is straight horizontally, and then using this level to make sure it's angled correctly. So currently I have it set up at about 115-inch wheelbase, which is kind of long. I might play around with that a little bit. Really what was driving that was making sure that when this axle comes up, you know, I have plenty of room around, you know, the front of the motor. So we'll see what I end up doing. During that axle truss build, I did have these tacked on. These are pretty simple. These really only go in one spot. I just set them up here. I set them level when the truss was level, and I tacked the lower links on. This is really good to put on first, because then now I can just work on mounting the lower links to the frame. They're most likely going to end up somewhere around here. I already cleaned up the frame nice and shiny, nice and clean, removed all the old brackets. So I'm gonna get a heim joint, get some PVC, and just cut it and see where that link will end up. All right, so I'm using these heim joints. These are the same ones I use in the rear. They're massive. They're the same that I'm gonna use on top and bottom. Both the axle side and the frame side, I'm gonna use these high misalignment spacers. You can just see just how heavy duty these are. Just a little extra detail. When I set these up first time, I always leave like a 1/4 inch gap. I thread this as far towards the heim as possible, as far out basically, and then I leave a 1/4 inch gap between this and this pipe adapter. All right, so I have this PVC just mocking up how the lower link should look. I like where this is going. I think this is a reasonable amount of triangulation. And where it sits now, I get, you know, just about 4 degrees. You want to keep this under 10 degrees. So I'm way under that, which is good. And then I'm going to use this frame mount style bracket. And it's going to probably end up around here. You see where this frame curves down and then gets flat? I want this to be as low as possible, so I'm gonna end up mounting it probably where it's flat. It'll be easier to locate this, and then I'll turn it in however far I need to, so those are nice and straight. And then I'll get a nice fat fillet weld there, and then I can reinforce the frame on this side for my upper links. So if you're building the rear and front forelinks on your truck, the way that I am able to translate, you know, ride height from the front to rear, I already finished the rear forelinks, and I basically brought the axle up to the truck frame at ride height based on, you know, where I decided how much up travel I should get, as well as when I designed the forelink, the upper link needs to be horizontal. So that told me how to put this wheel, the rear axle, back at ride height. From there, I take this little laser level. Hard to see the laser, but I have it centered on the center of this axle, and then it's shooting across all the way to the front axle. And you probably can't see it, but it shows the center of this axle. And because this laser is shooting a perfectly horizontal line and the truck is perfectly level, you see with these pipe stands I'm able to perfectly level the truck. I use a level up here, and I get the truck perfectly level. That allows me to use true level as an actual measurement, versus if the truck wasn't level and I shoot a perfectly level line, then you'd have to do something relative. But in this case, my datum, all of it starts at perfect horizontal and perfect level. That allows me to translate this laser line from the rear to the front, to be able to accurately, you know, put everything at ride height. And that helps because at this ride height that was driven off at the rear end, I'm translating that to the front. I can then control exactly where horizontal should be for my upper link. And this is critical to have less than 100% anti-squat for this type of truck. So I'm doing some weird stuff. I'm trying to center my axle. So I'm using a laser. I have this little jig set up on both sides to help me get a measurement for the center of my axle, so I can mark it on my truss. So I just divided this length by 2, and then I used my laser to mark that distance in half, and then transpose it up to my truss. And I did the same thing on the frame. I'm using tape because the pen mark shows up easier. So right now I have the laser centered in between the frame, and you can see my axle needs to move over, just a little bit of a 1/4 inch over to the right. This really helps you be a little bit more accurate. It takes a lot of time because what I'm going to have to do is push the axle over. I'm going to have to recheck my ride height and my level again. And then I can tack on my lower mount to the lower frame mount. So now we have the axle pushed over. I have my laser nice and lined up with the frame, lined up with my truss. My plumb bobs are centered on the truss on both sides. And I have a PVC pipe in my heim joint shooting over to the frame mounted side of the axle. And all I'm doing is trying to get this as straight as possible so that when we're at ride height, the heims are perfectly straight. So you can see this is turned out. It's probably about 20 degrees. And at this point, I can probably just tack this on. So I'm about ready to tack in my lower brackets. I went ahead and just finish welded this top plate to this bracket. I added this bolt inside just in case the heat makes it warp. I'll be able to remove these. This allows my heims to slide in without an issue in case of warping. All right, so I have my PVC aligned, and I was able to just tack in my lower brackets. And that's about how they're gonna look. Nice and straight. I have a nice angle over here, and then we wanna keep our lower links less than 10 degrees. And I'm at about 4 degrees, 4.1 degrees. Yeah, so you want to keep the lowers less than 10. These are at 4. That's good. And our uppers, we're gonna shoot for 0 degrees on the uppers at right height. All right, we're moving on to the upper link. That's woody. But anyways, we have this upper link just kind of chilling over there on the truss. And I have this crazy assembly going on here. It's gonna have this huge cantilever arm that I'm gonna build into the frame slider. So right now, this upper link is the same length as the lower link. That kind of dictates where this bracket will go on this side of the frame. So this is about where it ends up. It is resting on that lower link. You can kind of tie those in together. I'm using these tube mounted brackets. But the cool thing is, the way it sits now, my upper is exactly level, which is where you want to be at. Your upper should be 0 degrees to obtain that less than 100% anti-squat. So I think I'm going to try to run with this. I'm going to end up using a 1/4 inch thickness 2x2 tubing. Same thing I used on the rear link. This cross member here is 1/4 inch thick, and it's a 2x2. I use the same thing there, and then obviously I'm going to need to figure out how to strengthen it and figure out where I can triangulate that. I'm also going to tie the roll cage in to this bar, try to tie everything in together, and then I obviously need to do some kind of triangulation so that doesn't just rip off. All right, so I went ahead and just made this plate to reinforce the frame. It ends up overlapping this 2x2 nicely. And I created these plug holes so I can weld it until it's a little bit stiffer, but I should be able to get a nice weld around the whole plate. I mocked up this 2x2. This is not the actual 2x2 that's going to be used. And I think I like where this bracket sits. You can see that this is about horizontal. And putting it out really wide like this gives me a lot of triangulation in the link, which is what I'm going for. The lowers, I have a good amount of angle, but the more I have, you know, the better this axle is going to stay in the center. So from here, it looks good. It looks kind of funny coming out here. But I don't want to lower this point at all. So if I end up lowering that point, then this becomes too low. And then my axle separation, or not my axle, my bracket separation from the upper and the lower isn't going to be enough. So I really shouldn't bring this bracket lower, because then these are not going to be separated enough. Because right now, the way it sits at ride height, this link is right about at level, and there's a reasonable amount of separation, and there's plenty of triangulation. So I know this looks like a giant mess, but if you look at it, this is kind of what it looks like when the axle's all the way down, and this is up for the most part. It's going to go a little bit higher, but what I wanted to see was how these links will respond when they're at this angle. So I have it mocked up pretty good, same way here. This PVC seems to hold it good enough, and I have obviously the crane holding it. But you can see that what I'm trying to avoid is obviously contacting the links, and then also I'm trying to avoid hitting the engine mount. I already know that I'm going to have to cut this part of the frame. You see how it swoops down? It totally gets in the way. So I'll just end up cutting the frame here. I just don't want this link to interfere with my engine mount, so I don't have to redo that. But this axle's dropped down quite a bit, and we still have pretty good amount of clearance between this top link and the engine mount, and we're almost centered. If you see, this is where the link is. This is the center of the axle. So I like the triangulation, and I think this will work, and it won't hit my engine mount. Alright, so I have this finally officially mocked up. I have my 2x2 cut, and I welded a plate on to make it nice and clean on the outside. I'm using a bunch of clamps and 90-degree angles. We are level there, we're level there. You can see this is going to be a huge cantilever, so I'm going to for sure put some kind of pipe from here to here to support it on both sides. But this is basically as wide as I want it to go. You can see all that angle on this top link. Tons of angle there. Nice and clamped in. I think this is ready to be tacked. All right, so we got this bad boy tacked in. See how that looks. Look at the upper link, we're about exactly at horizontal at ride height, which is exactly what I was aiming for. We have a reasonable amount of bracket separation. I think this will do. The hardest part here will be matching it up exactly on that side. So what I'm gonna do is just start exactly how I did over here, and I'm gonna cut out me another plate, drill it, and mount it on. I'm underneath the truck right now, and what I need to do is locate the position of this plate and this tube on the other side. And so what I came up with, I'm using this drywall square. It's a really long square. I have it clamped up to this plate, nice and flush, and then it goes up and then shoots across 90 degrees. And then now I have this datum point where I can mark here, and then I can just measure off that line to measure back where the tube and the plate is, so it can be nice and symmetric. I'm sure there's other ways to do it, but this is what I found to work. Alright, so I have all my brackets welded on the frame. I just finished up matching this side to the other side. The only brackets that I haven't welded up are the top two on this axle. Right now I have them clamped down at approximately the same location using these clamps, and what my plan is to articulate the axle and just make sure that these links aren't going to interfere with the frame in a way that I can't easily adjust. The worst case is that I just bring these out a little bit wider to clear the frame. Yeah, that's how they look so far. I'm using this late, and before I can actually do that, I'm going to have to cut or notch this frame. I want to keep as much of this frame as possible. My VIN tag is here, so I still want this to be driven on the street, even though it would look ridiculous. So right now I'm aiming for 6.5 inches of up travel. So with the truss is the first thing that's going to hit the frame. So this is set at, the laser set at 6.5 inches. So this means that I'm able to keep this bracket, factory bracket here, and half of this tube. And I want to do that because this is what holds the front clip in place. So that saves me some time by just spending a little bit of time thinking about, you know, where this axle is going to go. So what I can do now is just draw a nice curve. This is as high as I need to go, and I'll just draw a nice curve. All right, so I finished up the cut. This is where it's at. I really wanted to keep this mount because that's going to hold the front clip. So really simple cut. Maybe do the same on both sides. The next thing to do here is I'm going to articulate this axle and double check that these links are in the right location. So this is where it's at full articulation. Doesn't look like much, but that's 7 inches up travel here on this axle, and that's 7 inches down for a total of 14. And what I'm basically trying to look at is trying to see if there's any interference with the links and the engine mounts. So we can see this is where the DOM will be. Okay, we can get plenty of clearance between that. So this will be good. And what I'm looking at is where these upper links will go. These two right here. We'll go ahead and tack those in now. All right, so we got the 4 links finally in there. Take a look at that. That's really good. Double triangulated. Look at those angles. Right about at right height. Take a look at how stiff it is. Really good. So I'm not exactly done, finished with reinforcing this, I guess this tubing that's holding the upper link. You can see I was able to weld it into the roll cage up there. So there's a nice connection, but there's this huge cantilever lever arm on there, so I'm going to probably end up incorporating this into the rails for the side. That has a lot of force pushing on that because it's so long, but it's worth it because of the number of the angle I can get on those. With these still being wide, I get a ton of angle. So I'm hitting the engine mount a little bit there, so I might clearance that, but this is about full articulation. Plenty of clearance over there, plenty of triangulation.